What is energy? Now, right now we're in the fall season, and you notice that the leaves have fallen from the trees and they're on the ground and they don't move, they don't stay in one place the entire time. What they do is they move around. That's because the leaves are being blown about by wind, and wind is a type of energy. That's because wind causes the leaves to change its position. And also, there's some work involved. And so we can conclude that energy is the ability to do work or cause change on an object. There are different types of energy or different forms of energy. We have light energy, we have thermal energy, we have wind energy, and hydroelectric energy, but we'll talk about that at a later time. Now, there are two kinds of energy. The first one is called kinetic energy, and that's energy in motion. So anything that moves, is kinetic energy. The ball and the airplane that flew across the screen, they both possess kinetic energy because they were moving. Another kind of energy is called potential energy, and that's energy that's stored. So, for example, this ball that's about to fall at the edge of the box. Currently, it possesses potential energy because the energy is being stored. It's currently not moving, but it will move eventually. So if you apply force to the ball, it's going to fall at the edge of the box and it's going to bounce down on the ground. So now at that point, it now possesses kinetic energy. And so potential energy can be converted to kinetic energy, energy in motion. So we have energy that's stored that's being converted to energy in motion. Another way to take a look at it is by calculating kinetic and potential energy using this formula. So we have kinetic energy, that is, the formula is Ke equals 1/2 multiplied by the mass of the object in kilograms multiplied by the velocity of the object in meters per second squared. Potential energy is Pe equals weight in newtons multiplied by the height of the object in meters. Now let's go ahead and compare kinetic and potential energy in a moving system. For example, this roller coaster. So what I'll do is I'll play the video twice, and I want you to pay attention to the graph, potential energy and kinetic energy. So notice that potential is the graph in blue, and kinetic energy is the graph in green. At this point, if you're working with a partner, I want you to discuss with your partner what you noticed about the potential and kinetic energy of the roller coaster as it moved across the different hills and loops. Next, I want you to locate the point at which there was greatest potential energy. So at which point does the roller coaster possess the greatest potential energy? So remember, in the graph shown, potential energy is graphed in blue. Is it location 1, location 2, or location 3? If you said that location 1 had the greatest potential energy, then you're correct. Location 1 had the greatest potential energy because if you take a look at the hills and loops that the roller coaster moves through, notice that the hill on location 1 is the highest. Therefore, it will only possess the greatest potential energy. Next, I want you to find the location at which there's least potential energy. Is it location 1, location 2, or location 3? If you said that location 1 had the least kinetic energy, then you're correct. At this point, the reason for this is that there's greatest potential energy in location 1. Therefore, if there's greatest potential energy, there would be least kinetic energy. The roller coaster is currently not moving at a high speed, so it only makes sense for it to have the least kinetic energy. Next, I want you to find the location at which there's greatest kinetic energy? Is it location 1, location 2, or location 3? Where would have the greatest kinetic energy? Now, if you said location 2 had the greatest kinetic energy, then you're correct. At this point, the roller coaster is at maximum velocity because it came from this really steep hill. And so it would only make sense for it to possess the greatest kinetic energy because kinetic energy is energy in motion. We're talking about movement, and so it's moving really fast at this location. Last, I want you to find where it would be the least potential energy. Is it location 1, location 2, or location 3? If you said location 2 had the least potential energy, then you're correct. At this point, at this location, the roller coaster was moving at a really fast velocity, really fast speed. Therefore, it's not storing the energy, the energy is moving. So therefore, it would only make sense for it to have the least potential energy. Now, let's think about the relationship among kinetic and potential energy. What can we say about the two? And we can make a conclusion that as potential energy is the greatest, then kinetic energy is the least, shown on the graph to the right. Notice that potential energy, whenever it reached the greatest potential energy, there would be the least kinetic energy. We can also say that as potential energy is the least, kinetic energy is the greatest, shown on a graph to the right. So notice that as kinetic energy is the greatest, potential energy is the least. And so potential energy and kinetic energy fluctuate in the moving system depending on where it's located and how that energy is being used. Now what I want you to do is answer the questions by clicking on Think. And there's multiple choice questions for you to think about.